you to everyone for coming to our webinar. We've got some great panelists lined up for you this time. We're hoping to enlighten everyone that has come to these sessions to be able to get a better insight and kind of understanding of CO2 utilization and the opportunities available in decarbonisation. Hopefully that will help to set up if you're interested in entering the X Prize, as well as participating in our carbon hack, which make sure to sign up if you are interested, and help to generate some great ideas that we can actually use to address our CO2 waste. To start off, I'll introduce our panel members. So we have 3 esteemed panel members with us today that we've been very fortunate that they have given us some of their time. So we have Professor Paul Webley. He's currently the director of the Monash Woodside Energy Partnership. He was previously the head of department here at Chemical Engineering, and he worked extensively in CO2 utilization. Then we have Stephan, who is a PhD student within that Woodside and Monash Energy Partnership, and he's just started his PhD working in the business area. And then we have Khanh, who is a Monash student who did some work with the Chemical Engineering department on using CO2. So if we want to, we'll get started. So Paul will be speaking first. So whenever you're ready, Paul.
Great, thanks, Brian. I'll just get my screen up and running. So I'm assuming everyone can see that. Like the slideshow, and is that the right settings or the wrong way around? Thanks, Brian. So look, thank you very much for this opportunity to talk to the folks out there about this whole really interesting area of CO2 utilization, which really wasn't on the radar up until about 5 or 10 years ago. CO2 was always seen as a pollutant, and the way we were going to reduce CO2 was just not produce it, which is of course still the major way we should be looking at decarbonising. But the first question when someone says to me, "What are you working on?" and I say, "I'm working on carbon dioxide utilization," they say, "Well, why are you doing that?" And the reason why is it is carbon after all. Carbon is a very valuable molecule. We're made of carbon, and all the plants and biomass are made of carbon. So potentially we have a feedstock that we could potentially use to create not just value, but to create jobs, to drive the economy. And so really it is something we should be looking at using. And so if you look at that vision quote that I have up there, it's a useful and marketable product from the capture and conversion of emitted carbon adds value or provides environmental, social, or other benefits. And the little graph that below that really shows why we actually cannot just rely on not producing CO2 as the final solution, because we will find that there are some sectors of our economy which are just very difficult to replace. Power production, we can phase out coal and better renewables. A lot of the heating we can do that. And so a lot of the CO2 can be reduced by switching to renewables, but there's a portion of our society that remains what we call very hard to abate sectors. And these are things like CO2 released when you make steel, when you make aluminium, when you make cement, when you make chemicals, concrete. So when we make a lot of these things, we release CO2 as inherent in the process. It's not just from the heating and the power requirement. It's actually what we call scope 1 emissions that's directly coming out of the process. And those are very hard to reduce. And so if you look at this graph here, this shows you emissions that we as humans release as a function of time. And at the moment, we're at the peak. We always hope we're at the peak in 2020. In fact, over at 2020, we did have an 8% reduction due to COVID last year in CO2 emissions, but unfortunately, we've probably more than made up for that already. But if we project ahead, if we don't do something about removing carbon dioxide and actually sequestering it, we're going to end up with that green shaded area where it's very hard to avoid those emissions. And so we do need to look for ways of capturing the CO2, removing it deliberately, and doing something with it. Now, the most popular and probably the biggest component of that will be so-called carbon capture and storage. But carbon capture and storage is very expensive, and there's no revenue stream from that. When you capture CO2 and you store it underground, unless there's some tax incentive like in the USA to do that, there's no revenue stream from that. And so it's very difficult to make a business out of that. And we generally don't do things unless we can make a business out of it. So utilization is one of the options that we can look at, and it can potentially add a value stream. So what is it? So just very basically in this diagram, we take the CO2 waste stream from any source really. It can be a flue gas stream. It can be a concentrated stream from a beverage bottling plant. It can be even air, where it's only 400 ppm. And we capture that CO2, and then we go through a process. It can either be a process of mineral carbonization. It can be a chemical conversion process. It can be biological processes, and there are many, many types out there, and some of the other speakers today will talk about that. And then we end up producing chemicals or fuels or construction materials or other things. That's the final captured form of that CO2. And if we're clever about it, we can capture it in long life uses, and so it's permanently captured. If it is re-released as a fuel, perhaps burnt, it goes back into the air. We then have to recapture it from the air and put it back in again. And so that's the concept of CO2 utilization. And this very busy diagram shows you all of the various uses of captured CO2. And I'm not going to go through all of them, but you'll see, particularly the ones that have got the little orange boxes around them, some of the more popular ways that are currently under intense investigation. How do we make green methanol, for example? If we have a source of carbon dioxide, perhaps from a landfill, which is renewable, and we have a source of hydrogen, we can make methanol, and that's a green methanol product, and it hasn't used any fossil fuels. Can we take algae to sequester CO2 and make useful things, fuels and food from algae? And so on and so forth. So you can see in that diagram, there are many, many opportunities for CO2 usage. And you might think, oh, well, why, if this is such a great idea, why isn't everyone doing this? And of course, there's the snag, and the snag is thermodynamics. And many of you are engineers and you've studied thermodynamics, and thermodynamics says if you want to take a low energy product and make it into a highly valuable high energy product, you have to put energy in. And all of the energy that we put into things is usually associated with CO2 production. And so you end up chasing your tail, you capture CO2, you put energy in, you produce CO2. And so we have to be very mindful about when we do a CO2 capture process and a conversion process, we need to be mindful of where does the CO2 eventually end up, and where is the energy coming from for us to convert that CO2 into something useful. That energy must come from a renewable resource. It must come from wind, from solar PV, from geothermal, whatever that source must be. It must be a green source which does not itself emit CO2. So that's really important. And preferably, we should have the CO2 end up as a product which has a very long lifetime and isn't re-emitted as CO2. So those are the sort of governing principles around the conversion processes. Now, this is not something that I just dreamt up one night. This is something that people have talked about for many, many years. And here is a list of really just 5 or 10 companies that are already working very actively to make products out of CO2. You can see some of the companies there. There's Nordic Blue Crude. They're making what they call e-fuels. Blue Planet is combining CO2 with cement to make carbonated concretes. Carbon to Chem is a project in Germany to convert CO2 from a steel mill together with hydrogen from electrolysis to make green methanol. Polymers are being made. Nanotech is biological conversion of chemicals, of CO2 into chemicals. So you can see there's a lot of companies. Unfortunately, there's none in Australia yet. We plan to change that through the partnership. So we're very close to hopefully pushing that off. And so how can I actually use the CO2 utilization to stimulate other industries is a really important point. It's not just the industry by itself. It helps to produce new products. So for example, a lot of people are very interested in hydrogen. Hydrogen can be used for things like putting into the gas pipeline or for driving trucks and cars and trains and so on. But at the moment, it's very, very expensive. And so many people create a hydrogen hub and they don't really know what to do with the hydrogen because they don't have a customer for that. CO2 is one opportunity where we can generate hydrogen, react it with a source of CO2, and produce a valuable product like methanol. And so now we have a product that we can sell to get value from, and we've also solved the CO2 problem. So in a sense, it can help stimulate the hydrogen economy. Construction, if we really think creatively, and we've recently had a team of mighty students looking at how do we really make a very powerful laminated timber product, which can sequester more CO2 than the conventional products. And if we make a very strong timber, can we replace conventional construction materials? And that was a fabulous project with some really interesting outcomes that will continue. So you can see that this concept of CO2 utilization actually stimulates a lot of other areas. Soil char, of course, is a topic of enormous discussion at the moment, and as a good example of potentially taking CO2 and converting it into soil char, and then putting that soil char back into the soil. So, and that can be done at a very large scale, and again, as a valuable product. So it comes down to this concept that I'm trying to add value to something that is traditionally I've always thought of as a waste product. CO2 utilization is a multidisciplinary activity. It's not chemical engineering, it's not mechanical, and it's not even just engineering, it's business. It's the entire spectrum of disciplines are needed to make a market and make an economy out of it. And so at Monash University, Woodside and Monash have got together and have launched what we call the ARC Research Hub for Carbon Reuse and Transforming Emissions. We've applied for this through the government. Hasn't been announced yet. We're all very hopeful that we can pull this off. You can see on this slide, we've got a lot of companies involved. We've got a lot of universities involved. And this is a major $10 million effort over 5 years, which will see research coming into Monash and the other universities and working very closely with all of those partners there to create a set of programs that you can see here in carbon capture and chemical conversion, biochemical conversion, looking at enabling technologies to help that conversion. And then finally, also looking at business models and low carbon energy policy that will be needed to activate the CO2 utilization market. So this hub is called ARC Recreate. Fingers crossed we get it announced in July, and we're up and running, and then we will be on the hunt for PhD students, master students, as many students as we can get to join this very, very important mission that I think is going to be so critical to not just getting hard to abate carbon, but really providing a business model and a business opportunity for the next generation of engineers to come out and say, maybe I will start up a company that does CO2 conversion to biochar. Maybe there's an opportunity there for me. So I think it's a very exciting times. And with that, I thank you all and happy to take any questions.
Cool. Thank you for that. That was very enlightening. So if any one of the attendees has a question, please feel free to put it in the Q&A and we'll pop it up. But we may as well kick things off. So Paul, what kind of makes CO2 quite difficult to use in terms of getting some value out of the industry?
So are you talking about the difficulty of conversion of it? Is that what you?
Yeah, I guess why it's so difficult to convert.
Yeah, I think there's a few reasons for that. CO2 is the end result of combustion, and so it's like the analogy would be like you made a fire with wood and you've got ashes left over after the fire, and someone says to you, "Can you make something useful with those ashes?" Well, that's pretty hard. You could probably make concrete with the ashes, but that's about it. There's nothing, you can't take the ash and reconvert it back into a tree. That's a very, very hard thing to do. So CO2 is very much the same thing. It's a very, very stable molecule, and it's thermodynamically so stable that we have to break apart these very strong carbon-oxygen bonds in order to convert it to something that's different from CO2. And to do that, we either have to inject electrons into it, or we have to inject photons into it, or we have to react it with another molecule like hydrogen. The only things that are easy to do with CO2 is to make carbonates. And nature has done this already. So a lot of the source of CO2 sinks in the world is CO2 going into the oceans and making carbonates and going into the earth and making carbonates. And so one of the more popular ways to look at CO2 utilization that doesn't require a lot of energy is making carbonates. So really it's physics is against us. And I think there's also a cultural mindset. We live in a society where people like to throw away things. They see flue gas as an emission, throw it away, it has no value. And so I think it's going to require a cultural conversation and almost a psychological change of society to regard CO2 as actually, wow, this was actually quite a valuable molecule and we threw it away. If only we had known, we could have made all this neat stuff with it.
Yeah, I think we need a specific change in mindset, like how we changed our perception of natural gas, where we used to flare a lot of the natural gas where we were drilling up, but now found that it's actually such a useful compound. Have you been, so far, has there been any interesting developments, I guess, in industries kind of converting CO2 into useful products, or that you've seen or heard of?
Yes, I think there's been, I'm a part of a decarbonisation network in Europe called Decarb Connect. And it's a network of like-minded industries and people who are looking for opportunities to add value to CO2. And you'd be surprised at how much money there is out there from industry and from banks and from insurance companies to fund R&D to look at converting things to useful products. And I think probably the foremost ones at the moment are looking at biological methods for absorbing the CO2, either growing algae or some bacterial biomass, cyanobacteria, and then taking that biomass and nature's been doing this and perfecting it for millions of years. And can we as a human society take those processes, accelerate them, make them as fast as we can, and then see if we can make something useful out of that. So for an example, fish farms, do you know what they feed fish to grow? They feed them other fish that they've ground up. And so fish meal is fed to fish. Now that's just crazy. You could just take CO2 and grow fish food from CO2, and now you've captured a CO2 product that's a valuable product. And so that's in fact being done by some companies. And I think the other leading area where there's a lot of interest is in the mineral area. We always look for opportunities where the market is already established and where it's very large. And if you look at all the big things that we build as society, we build concrete structures, skyscrapers and houses and all sorts of things that are concrete. And so if we can get CO2 into concrete instead of releasing it when we make concrete, then we have an opportunity to sequester vast amounts permanently because we make so much and we use so much concrete. So those are just a couple of examples, Brian.
Cool. Thank you very much for that, Paul. We'll have some more time for more questions after all the presentations, but we'll move to our next panelist. Stephan, if you would like to present next.
Thank you, Brian. You just share my screen. Before I start, I'd also like to thank the Monash Energy Club for organizing this webinar series and for the opportunity to having me here today as a panelist and to speak to everyone. I am a PhD student with the marketing department of the Monash Business School, and I also work as a research assistant with the Woodside Monash Energy Partnership, where I support research projects that look into green hydrogen and carbon capture, utilization, and storage. My PhD project looks at carbon labeling and specifically carbon neutral certificates and their impact in the Australian energy sector. So let me begin by giving a bit of background information about carbon labels. Basically, a carbon label is an identifier on a product that provides information about the carbon intensity of that specific product. Most carbon labeling is done in one of two different ways. The first way is that a label can measure the total greenhouse gas emissions generated over the life cycle of a product. And then that information is provided in terms of like mostly grams or kilograms of CO2, as you can see here or here. And the second way is that a label can indicate how carbon intensive a product is relative to other products in the same category. So you can use, for instance, this kind of system where you distinguish between more or less carbon intensive products. Carbon neutral certificates, on the other hand, they can be given to products for which the sum of greenhouse gas emissions, in most cases that is CO2 emissions, is offset either by natural carbon sinks or by carbon credits. So in other words, a company whose products are certified as carbon neutral pays emission reductions to a third-party company in order to mitigate the emissions that they themselves produce. Similar to that of carbon label, A carbon neutral certificate can be applied, for instance, to a physical product, to a specific service, an organization, or like an entire organization. When that organization is like either offsetting or not producing CO2 at all through their supply chain or through the services they offer. Here, as you can see here, the most common or the predominant organization in Australia that does carbon certification is the Climate Active Carbon Neutral Certificate in Australia. So what is the impact of those carbon labels and neutral certificates? They can have an impact on the demand side as well as on the supply side. On the demand side, those labels and certificates allow consumers and customers to make an informed choice. If you want to compare products, for instance, that are using the same kind of metrics for their carbon intensity, those customers who are environmentally conscious, sustainable, they can choose the kind of products that have a smaller carbon footprint compared to other products. On the supply side, those labels can reduce carbon emission through market competition. So if your product has a heavier carbon footprint, you are at competitive disadvantage, and that creates pressure on your own products to reduce their carbon footprint by reducing your carbon emissions throughout your entire supply chain, not just your products, but also the raw materials that you source from other companies in order to stay competitive in the market. In my work, I look at my focus is on carbon label impact in the Australian energy sector. As you can see, Climate Active is the major organization that certifies products, services, and companies in Australia. You have different categories where you can have, like for instance, either a product, a service, an event, a building, a precinct, or an entire organization certified as carbon neutral. And as you can see, there are major utility and energy companies within Australia that have already some kind of carbon neutral certification within that scheme. So the question I'm trying to answer with my PhD project is the first one: what is the actual impact of these certifications? All these companies, they clearly state that they expect some kind of benefit from their efforts of reducing their carbon footprint, and the certification that comes along with such with these efforts and such reduction. So the expected benefits, they are primarily in the form of increased customer satisfaction, which then leads to higher customer retention rates, positive word of mouth, investor confidence, and also new customers that actively seek out these companies and products who are more sustainable than other organizations. The question though is, what is the actual impact? What's the real world impact? And this has to date in Australia never been measured in a systematic way here. So in my first question, I'm trying to produce the kind of data that are necessary to measure the real world impact of these certificates. In my second question, I'm trying to uncover the underlying mechanisms and factors that actually lead to more sustainable consumer behavior. These could be, for instance, a variety of socioeconomic attributes, along with behavioral and psychological factors that influence those decision-making processes. Beyond individual consumers, I will also look at some other factors that influence decision-making. For instance, for larger organizations and companies. For example, under which circumstances would a company to choose its electricity or energy from a carbon neutral certified energy provider? And then what would be the specific impact of that choice for the company of being less carbon neutral. So for that, my PhD project, through my project, I'm going to conduct a comprehensive market research study and design surveys and questionnaires that allow me to gather, I suppose, enough data that from which I can derive insights and conclusions into these schemes and mechanisms. So the impact I'm trying to achieve through my work has several different aspects. On the one hand, I'm trying to understand what is the impact of carbon neutral certificates. My project will support sustainability conscious businesses in choosing the most effective or effective carbon neutral product strategies. So when those companies see in which way those schemes work, they can then adjust their strategies accordingly to attract more customers or to distinguish themselves from competitors. This then in turn has the potential to drive pro-environmental consumer behavior and voluntary climate action, not just in the Australian energy sector, but pretty much in any sector or industry where such labels are being used. My research will also support policymakers with insights that will, I guess, enable them to implement meaningful and to implement meaningful low carbon legislation and regulation. And finally, I'm also trying to create market insights for decision makers in, let's say, NGOs, nonprofit, and other civil society organizations like Climate Active Australia that will inform their organizational strategies and long-term objectives and goals and how to get to these goals. Yeah, thank you. Any questions so far?
Oh, thanks for that, Stephan. That was a great presentation and a great insight into your research and at least some of the other energy research that is being conducted at Monash that people could look into. So I'll start off the questions. Has the carbon certificate already been kind of successfully implemented in any other countries, or are specific countries already looking to really develop and implement a plan that will get this working?
Yeah, let me just go back a couple of slides. As you can see here, different countries use different kind of schemes and certifications, and I think the UK at the moment is the most advanced country in terms of applying those schemes to products. But for the energy sector, that has not really been done anywhere so far, and this is also part of like what kind of drew me to this line of research. I'm originally from Germany, and I grew up in a very environmentally conscious and sustainable environment where this kind of thinking was, I guess, at the forefront of everyday life. I remember, for instance, when I grew up, we were separating waste into 6 or 7 different type of recycling and waste bins. And Germany was also always at the forefront of renewable energy leaderships. And I've been living here in Australia now for 5 years. And I see that Australia has such a tremendous potential for renewable energy utilization. There's so many resources, but the mindset and the policy agenda here is very different. So I am very curious in understanding why is this so different to other countries, even though Australia has a lot more potential when it comes to those kind of resources, and understanding, I guess, the underlying mechanisms and factors that distinguish the schemes and I guess certificates that we use here to those in other countries.
Okay, awesome. So we've got a question from Liam. So do you think the carbon certification scheme will extend to larger manufacturing industries, such as construction materials or steel? And just to lead on to that, are you seeing, well, from what you've done so far, have you seen that the market is willing to adopt a carbon label, or does it need to be more of a push from governments?
Yeah, that's an interesting question. So the way I've just started my project, so I haven't gotten any like data to substantiate that yet. But my perception so far is that there is a strong interest industry-wide to adopt such kind of schemes. I'm just going to go back to my slide here. As you can see on the Climate Active one, there's a variety of different companies who have started to adopt such schemes and certificates, not just energy companies, but there's entire organizations, also banks, telecommunication companies, and manufacturers will also, I think, start to look into these schemes if they want to distinguish themselves from other companies. The one challenge I see is to establish a sort of reliable scheme, like as a certain guarantee of origin sort of scheme that can really keep track of all those carbon emissions that a company has through its products. And those can be quite extensive in some industries where you have raw materials or products that come from other countries. But the trend is that more and more business and industries will adopt these schemes, and that can be facilitated by policymakers, definitely. I think in Europe it is to some extent facilitated already. There's stronger consumer regulation and stronger environmental regulation. Australia is lagging a bit behind here, but Europe has recently proposed a carbon border tax, for instance, where it would put an additional tax on any products coming from anywhere else outside the European Union that are not carbon neutral. So potentially everybody wants to export to Europe, and in the future other regions that have such a carbon border tax will have to come up with such a scheme, and governments can definitely facilitate that if they want to stay competitive and make their own companies competitive in the market.
Okay, awesome, Stephan. Thanks for that. We'll circle back and have, if there are more questions, we'll come back to you at the end after Khanh has finished speaking. Khanh, would you like to present next?
Yes, for sure. Let me share my screen.
Thank you.
So, hello everyone. My name is Khanh, and yeah, it's my pleasure to be here today to talk about what I had done so far in my summer research program last summer. So just a little bit about myself. I'm doing chemical engineering and pharmaceutical science. And so I'm an undergrad student in my 4th year. So last summer, I had the chance to participate in the summer research program, and I work under direct supervisor of Associate Professor Ashad, and working on coating the monolith with a catalyst for the conversion of carbon dioxide into syngas. So I think you can see the topic of my research is quite similar as quite a lot of other good side projects. So we focus on the carbon utilization, capture, and conversion. So for example, so just a little bit about the presentation agenda. So I will talk a little bit about the background, then talk about which objective and which is my focus during the research, and then talk a little bit about the experimental findings and conclusion. So for some background, as I say, we focus on the carbon capture, utilization, and conversion. So in my research, for an example, we will convert methane and carbon dioxide, as you may know, it is two greenhouse gases, into syngas, a mixture of carbon monoxide and hydrogen. So this reaction is known as dry reforming of methane, DRM reaction. It is quite an important reaction in the chemical engineering industry, because it's not only reduce carbon dioxide and methane to greenhouse gases, but it also produces syngas. And I think you can see from the diagram, syngas actually has a really wide application. It can be used for the production of other chemicals and can be used for power generation as well. So it is a really nice way to, convert a greenhouse gas such as carbon dioxide into a really useful product, which has many applications in the industry. So for the research problem, as I mentioned before, the RM reaction, it only occurs if we heat it at really high temperature, approximately like 800 degrees Celsius, under the presence of a catalyst as well. However, the main problem is the catalyst. So the promising candidate for the catalyst for the RM reaction at the moment is nickel catalyst, because they abundant, they cost efficient, and they has a high catalytic activity as well. However, during the reaction, this catalyst is quickly deactivated due to the carbon formation as a side reaction of DRM. Therefore, I didn't really directly working on the DRM reaction line setup and actually do the experiment, but I focus on another field of this reaction, which is finding a way to optimize the coating process of the monolith with the catalyst, so that the lifetime and the performance of the catalyst is optimized. So in our cases, we want to have the coated monolith with the most uniform, adherent, and of course, has the reasonable amount of catalyst on it after coating. So that is the aim of the research. So I work along with one of Ashraf PhD student for the experimental work, and we conducted quite a number of experimentation rounds. And I think today I would like to introduce you the first 3 rounds of our experiments. So basically, how we conducted our experiments between rounds, they're quite similar. We only change quite a number of parameters between experimentation rounds so that we can fully investigate how those parameters affect our final results. So for the first round, we synthesize the catalyst. We make a 15% weight catalyst suspension, and then we add 40 ml of BBB solution. So this one is kind of a binder, so it will increase the viscosity of the catalyst suspension, because we need to reach a sufficient viscosity for the catalyst to deposit on the plate. And then we basically deep coat the substrate into the catalyst suspension. Then we dry it in the oven, and then we anneal it at high temperature for around 2 hours. So after this round of experiments, as you can see, we got quite a number of catalysts onto the plate. It looked quite thick, but it was not really uniform. So you can see we got more catalyst in the middle of the plate and less catalyst at the edge of the plate. So it's not really uniform. And actually, something else I have to mention here is that it's not only not uniform, but it's also not adherent, because just after a few days after I took this picture, all the catalyst came off the plate. So we just didn't have anything on the plate. It just fallen off. So we can say that it's actually not ideal, and we have to change something on our experiment so that the coating can be more uniform and more adherent. We went through quite a lot of literature review, and we think that if we increase the viscosity of the catalyst solution too much, it may lead to the issues as we observed before, which is not uniform coating, and the catalyst is easily coming off the plate after a few days. Therefore, we changed the way we do the experiments. Instead of making a catalyst suspension, which is maybe too viscous, we make a catalyst solution, and this time the catalyst concentration in the solution is just 8%. We also add some PVP so that the catalyst cannot be too high, but it cannot be too low either. Otherwise, we can't get any catalyst deposited on the plate. And just the same as the first round, we also dip coat the substrate into the catalyst solution, and then we dry and anneal it at high temperature. And actually, we're quite happy with what we got after this time, because, you know, it don't look really uniform after coating and drying, but after 2 hours of annealing, we got quite a uniform coating onto the plate. And it's really good that even after a few days, even at the end of my research, before I finished my program, the catalyst was still really adherent on the plate. It didn't really come off at all. And however, for this time, as you can see from the graph, the amount of catalyst can be coated on the plate. It just increased significantly after the first coating, and for the following coating, it just like slightly increased and then finally decreased after annealing. So when we saw this graph, we thought that maybe annealing temperature might have an effect on the final result. I mean, the final amount of catalyst can be coated on the plate. That's why we came with the last experimentation I want to introduce today. But this time, we changed something on the annealing temperature and time as well. And this is what we got. We got the catalyst mass drop more significantly when we anneal it at higher temperature. So it seems like the annealing temperature had a really negative effect on the adherence of the plate. But actually, after discuss with my supervisor, he said it just may be due to the loss of water and functional group after annealing. So if we got quite a uniform and adherent coating in the second round, so we should stick with that for future coating. So just following the advice from my supervisor, in some next round, we still use the experimental procedure we developed in the second round, which gave us the most uniform coating and the reasonable amount of catalyst deposited on the plate. And we also can give some conclusion that the catalyst coating is more uniform when we dip coat the substrate in a catalyst solution with a sufficient viscosity, rather than the catalyst suspension. Maybe the viscosity is so high for an efficient coating. And then, however, as I mentioned before, we didn't really get much catalyst onto the plate in the second round compared to the first round. So in the future direction, we're thinking of a primer deposition. So what is a primer deposition? So basically, the primer can be synthesized from a powder such as PVB, and we will coat the substrate in the primer before we actually coat it with the catalyst, so that the powder can increase the adherence of the catalyst, so that more catalyst can be deposited onto the plate of the coating. And by this way, we hope that the coating adherence and the amount of catalyst on the plate will be increased more significantly. So that's the final result of my research. So, I mean, like, it's not has a really significant impact in general, but in fact, although I didn't really work directly on the DRM reaction, but hopefully these findings can help with the actual catalyst coating in the future to optimize the DRM reaction for the conversion of carbon dioxide into syngas. Yeah, thank you for listening. So
Well,
anyway,
thanks for that presentation, Khanh. It seems like you're working on some cutting-edge research that should have some large impact. So just a quick question. How did you find that experience since you're an undergrad? And I guess research is quite a big step from what you're used to. How did you find working on all this experimentation and kind of that kind of work? I think, yeah.
Yeah, it's actually quite challenging at first, I have to say, because before starting this research, I actually have no idea about carbon capture, conversion, and utilization and its potential as well. So I think just as quite a lot of other people I know about that, it's just some common sense, carbon dioxide is really harmful to the environment. And that's why when I first started this research, it's quite challenging because I couldn't really understand the idea behind this one. I think that's when I need to go through quite a lot of research papers just to gain some basic understanding and saw what other people are working on similar topics and what they had so far, what they found, and what needs to be investigated more. And I was just also lucky to work along with another PhD student with Arshad who guided me a lot on the way I should do the research and how I have to do, like what I need to do in an experiment.
Okay, awesome, thanks. So I'll open up the floor back to general for all the panel members, and we've got a great question here from Faisal. So Faisal was interested in knowing how, I guess, the students got involved in your research, so in particular Stephan and Khanh, and kind of the scope of the projects in the future. I also might expand this question in a bit to include Paul. Since most of our attendees are students, kind of if you guys could elaborate on how students could get involved and kind of pursue this kind of research in the state they are at the moment. So I guess, Paul, how could students get involved in working on CO2 utilization with Woodside and the Monash Partnership?
So absolutely. So as you saw with the hub that we've applied for, but even without the hub, Akshat is one of our theme leaders in the carbon management side. So we have three themes in the Monash Woodside Partnership. One is new energy, which involves anything to do with hydrogens, solar PV, things which enable us to decarbonize. The second one is a carbon theme. And that's around exactly what Khanh has just been talking about. How do we actually use CO2 or use natural gas and produce, in her case, syngas, but more generally any other compounds. And then the third one is around the business side and the analyzing change, and that's the side that Stephan is in. So I would encourage any students who are interested in working on any aspect of decarbonization to definitely contact us, either email me directly or go through our webpage, or yourself, Brian, through the Energy Club, and let us know what you're interested in. We have a wonderful growing cohort of students, undergrad students, postgrad students, The cohort is growing. And of course, we've got you haven't really talked about the X Prize that's coming up. That's another wonderful opportunity. So I think there's going to be so many opportunities to work in decarbonisation. It's such a broad field. It's so multidisciplinary that it really comes down to the imagination of the individual, what aspect you want to work on. And it can be multidisciplinary, and it can be as detailed or as superficial as you like. There's some opportunity for you to contribute to this exciting journey, really, really urgent journey that we all have to take.
Thanks for that, Paul. And I guess Stephan and Khanh, how did you guys get involved in particular with doing this research at Monash?
I'm gonna go first. I participated in a decarbonisation sprint a couple of months ago with the I think it was the Woodside Monash Energy Partnership. Paul, was it part of the partnership or?
Yep, absolutely. It was part of the partnership hosted that. Yep.
Yeah, so it was a decarbonisation sprint that organized, or like there was organized, and there were a couple of teams, and each team was background material was provided, and then each team would, I guess, in a like 3 or 4 hour session, come up with an idea or concept that could be developed and scaled up into a carbon utilization project. And I got to know a lot of the people who now work in the partnership. And that one, I think, student project, which was mentioned by Paul earlier, which actually made it into the further stages through that decarbonisation sprint. So it was very interesting.
Thanks, Stephan. And how did you get kind of involved, Khanh?
Yeah, so I'm not new to myself. So my research is under the engineering summer research program for undergrad students. And I got the offer from ASHA, so that's the way I get involved in this research. So actually, because it's under the summer research program for undergrad students, so although it seems really challenging, it was actually challenging, but the scope and the aim and the desire of the research, is suitable for an undergrad student like me. And then you can also get the support from other senior members and researchers as well. So yeah, that's how I get involved in the research.
Okay, awesome. Thanks, Khanh. I think we have one last question, which is just to finish off the webinar. So we've got a question from Liam. So Liam asks, to you, Khanh, is the monolith supported catalyst reactor the end goal for the design of this reaction, or is a different type of system, such as a fluidized bed, being investigated?
So as I mentioned before, like my research, my project, it's just a really small part in a bigger project to optimize the DRM reaction. So at the same time, when I finding a way to optimize the deep coating process of the monolith, other people are working on other aspects of the DRM reaction, such as the upstream temperature, the downstream temperature. When the DRM reaction occurs, it really has the impact on the performance of the reaction as well. And yeah, I saw my supervisor concerned about the shape of the monolith as well, because he argued that it might affect the adherence and the way the catalyst can perform. And yeah, I saw people looking at different things in the system as well, so just not only the catalyst coating.
Okay, awesome. Thanks, Khanh. So I think we're just about to finish. So thank you to our panelists for taking the time out of their busy schedules to come and kind of present us today. If you guys were able to gain some benefit and get some better insight into CO2 utilization and opportunities in decarbonisation. So don't forget, we have another webinar coming up next week on chemical pathways to converting CO2. So be sure to register. And thank you all for attending.